Okay, we're going to look at squared numbers, cube numbers, powers and index form and expanded form. So square numbers, as the name suggests, are numbers that can be used as whole numbers to create squares. So a 1 by 1 square is 1 by 1, will give us an answer of 1. A 2 by 2 square, an answer of 4. 3 by 3 square is going to be 9, and a 4 by 4 is going to give 16. So these numbers here, 1, 4, 9, 16, then 25, 36, 49, 64, etc., are all square numbers. And what that means is that a number multiplied by itself, for example, 4 multiplied by itself, 4, will give you the answer of 16, which is a square number. Now, we can shorten these to use powers. So, for example, this one, it's 1 to the power of 2, 2 to the power of 2, 3 to the power of 2, and 4 to the power of 2. And this use of this power indicates how many of that same number are in that particular equation. So let's look at this a little bit more broadly. So here is our base number, here is our power, okay? And what this means is that there are 2 of this digit here, this base number, in the actual equation. So 2 2s like that, and just multiply. So it's saying how many 3s are there? There's going to be 2. How many 4s are there? There's going to be 2. So whatever we change this number to indicates the number of that base number that's in your expanded form. Okay. So things to understand, this number here is your power or your index. This number here is your base number. So base number here is 3, the power is 2. Here the base number is 4, the power is 3. Okay, so now we look at cube numbers. So cube numbers follow on the same principle as square numbers, where square numbers create squares, cube numbers create cubes. And so here we have our 1, and there's 3 of them. That creates that 3 dimensions, that is a cube. Here we have a 2. How many 2s are there? There are 3 of them. 2 times 2 times 2. So they're going to create the 3 dimensions of our 2 by 2 by 2 cube. And 2 by 2 by 2 gives us 8. So 1 is a cube number, 8 is a cube number. 3 follows that pattern, so becomes 27 is a cube number. 4 follows that same pattern of 4 by 4 by 4. So they're the dimensions of our cube here, and that gives us our cube number of 64. Now for any of our index form, we can always express them as what we call expanded form. So we take that initial index form, here we've got 8 to the power of 5. So how many 8s are there going to be? There's going to be 5 of them. So it's going to be 8 multiplied by 8, multiplied by 8, multiplied by 8, multiplied by 8. This is 1, 2, 3, 4, 5, which matches up with our index form. So this one here is index form, this one here is expanded form. And sometimes you'll be asked to actually calculate the result of that, and you typically do that with your calculator, but sometimes you'll just be asked to go from expanded form to index form, or index form to expanded form. Okay, so this symbol here is square root. Now I've done it in red, you don't need to do it in red symbolically, you can just do it exactly writing it. So that means square root, and what it means is what number multiplied by itself. In other words, what squared number will create 25. So we know that 5 squared equals 5 times 5, and that equals 25. So the square root of 25 is one of those, which is 5, which we write up there like that. Okay. So let's have a look at another example. Okay. So if the square root of 25 is 5, then the square root of something like, say, 49 is going to be 7 times 7. So the square root of 49 is going to be 7. Okay. Square root of 64 is going to be 8. Square root of 81 is going to be 9. Now, as well as square root, we can also have cube root. Okay. So cube root, as perhaps the name suggests, is going to be where a number is multiplied by itself 3 times. So for example, if we put an 8 in here, we know that 2 cubed is 2 by 2 by 2, and that equals 8. So the cube root of 8 is going to be 2. Okay. So have a look at a different example. So if we look at, say, 27, 3 cubed is 3 times 3 times 3, and that equals 27. So the cube root of 27 is going to be 3.